Okay, here we have a really good question, and it's whether or not to add or subtract the 50%. Now, this is actually part of a different or a larger class of questions where you feel like you're arbitrarily applying a formula and you don't know whether to subtract from one or not, or whether to throw in the 50% or not. And usually in these types of questions, when you feel like it's just kind of throwing a dart at a dartboard to try to figure out the answer, a visual tends to give you a good grounding in the problem. So let's take a look at a visual of this problem. We have shoe sizes of American women. We have the average shoe size, the mean being 8.22, and then we have our standard deviation, 1.48. Using the empirical rule, what percentage of American women have shoe sizes less than? That's a key right there. So let me grab a brush here. So less than, that's going to come into play 12.66. And it says do not round your answer. So the empirical rule is referring to it's otherwise known as the 68, 95, 99.7 rule, as we see here. I think it can be useful to actually break it down further into chunks like you see in this drawing here. So instead of just thinking 68% is within one standard deviation, we can put that into 34% is one standard deviation to the right, 34% is one standard deviation to the left. And that 95, then we can subtract out the 68, divide by 2, and we have those 13.5s that are in between 1 and 2 standard deviations on the right and on the left, and so on. So the question here tells us that the mean is 8.22. Let's go ahead and write that here. So we have 8.22. Now we also know that one standard deviation is equal to 1.48. The problem tells us that right here. So that means if we wanted to, we could write out what each of these boundaries are. We would just add 1.48 to 8.22, and we would get 9.70. Then we could add it again, and we would get 11.18. And we could add it again, and what would we get? 12.66, which is what we should be getting there. 12.66. Now, one thing this drawing doesn't do, it doesn't show you that there's even stuff in the normal distribution beyond 3 standard deviations, which would be out here to the right and out here to the left. So how much is out there? Well, we know that 99.7% of the data is in between. It's within 3 standard deviations below and 3 standard deviations above. That means the rest of the data is outside of that range. So what is the rest of the data? Well, we could take 100% minus 99.7%, and we'd find that it's 0.3%. So that's the amount of data that's even more than 3 standard deviations away from the mean. Now, since we have 2 directions, we have the left and the right tail, we could split that in 2 so that we get 0.15% here and 0.15% here. And you know what? I wouldn't go through these calculations every time. Since you can use your notes, I would just copy the picture you have here in your notes. And in addition to all the percentages they list out, go ahead and put in that 0.15%. That goes from 3 standard deviations out to infinity in the left direction, and from 3 standard deviations above the mean out to infinity in the positive direction too. So you don't have to keep doing that on and on and on. This is just everything above 3 standard deviations. Okay, now the question asks us what percentage of American women have shoe sizes less than 12.66? Well, right here is 12.66. So that basically means all of this area, all the way out to infinity, is the area we're looking for. Again, because we're looking at less than. I mean, it's almost all the data. In fact, it is all the data except for this little tail, right? So if we want to know what percent is shaded in there, what percent of the women do have shoe sizes less than 12.66, it would be everything except this 0.15%. So it would be 100% minus 0.15. Now that's not 15%, that's 0.15. So that gives you 99.85%. Now, if we wanted to ask what percent have shoe sizes less than 97, or sorry, 9.7, we would look right here and we would just add up. Well, we have the 34, the 34, the 13.5, 2.35, 0.15. We could just add them all up and that would give us our answer. Maybe we want all the ones that have shoe sizes bigger than 9.7. Well, then we would just add up, let me change my color here. We would add up the 13.5, the 2.35, and the 0.15 because those are the areas of the normal distribution that are to the right of 9.70. So whether or not you need to add or subtract the 50% is typically whether or not you're going to the left or to the right. But I think if you draw it out, it makes much more sense than trying to kind of guess whether or not to add or subtract the 50% there using the charts.